All right, well, this is section 9.2 in Algebra, and I'm Mr. McDonell. And so here we are. We're going to take a look today at the second part of our lesson. A polynomial is the reverse of multiplying. What we've done on the first page is we talked about finding out what a GCF is. And as you know, GCF stands for greatest common factor. Well, the word that goes in here is called factoring. What we're going to talk about today and learn how to do today is something called factoring, and that is the reverse of multiplying. So let's just kind of jump right in here and go about it. Let's look at our 6a squared and our negative 8a. Well, between 6 and 8, the largest thing that goes into both of those is 2. And between a squared and a, the largest thing that goes into both of those is a. So 2a is our GCF. So I'm going to write that out front with the parentheses directly below our problem. Now, all we have to do is think backwards. Let's think of the problem that would have this as our answer. 2 times what is 6? Well, 2 times 3. A times what is a squared? Well, a times a is a squared. Now let's do the second half. 2 times what is negative 8? Well, that's negative 4. And we don't need any more a's because 2a times negative 4 is negative 8a. So here is the factored form of our problem number 6. Let's look down at number 7. Between 18, negative 6, and 12, what is the largest thing that goes into both of them? Did you think 6? I hope so. Now let's look at our variables. X cubed, x squared, and x. Well, since the last one just has one x, that's our GCF. So once again, let's write that out front with a parentheses underneath the other polynomial. 6x times what is 18x cubed? Well, that's 3x squared. Remember, you add your exponents for multiplying variables. Minus, and I like to put a 1 there because 1 times negative 6, or 6 times negative 1 is negative 6, and x times x is x squared. You don't need that 1, but you can put it on. And then lastly, plus 2, because 2 times 6x is 12x. Moving down, 15, negative 3, and 12. Looks like the GCF here is 3. And the smallest exponent between our variables is n squared. Did you pick up on that? The smallest exponent of each of our problems in the past is our GCF. Here it was 1a, 1x, and n squared. So let's put that 3n squared out front with our parentheses. Now let's fill it in on our own. 3 times what is 15? Obviously that's 5n squared minus 1n plus 4. Once again, you don't need that 1 there, but it sure is helpful if necessary. Now we're going to do a little review of our perfect squares. If you remember yesterday, we had 11 squared, 12 squared, and 13 squared, and we learned some tricks there. Let's review those 3 tricks. 11, 1 times 1 is a 1, and 1 plus 1 is a 2. So 11 squared is 121. 12 squared, 2 times 2 is 4, and 2 plus 2 is 4, so that's 144. 13 squared, 3 times 3 is a 9, and 3 plus 3 is a 6. Now that doesn't work for 14, but if you look at 13 squared is at 169. If you take those two and switch those, you get what 14 squared is. So 196. So here we go. As we look at our final page, what I'd like to do is you look at the next page and we're going to look at our perfect squares. And what I'm going to do is I'm going to write down these perfect squares. And I want to see if you can say them faster than I can write the answers down. Now, you can't begin until I start writing. So here we go. You're going to say 1 squared, and you're just going to say the answers as fast as you can. On your mark, get set, go. Try to keep up. You should know the squares that fast. Were you able to say 196 before I got to the bottom? I sure hope so. Keep practicing those, and we're going to learn them every day.